So I uploaded, so welcome back everybody. Over the weekend I uploaded, and the weekend means yesterday, the podcast, I don't know if it's called podcast, but whatever it is, module, I uploaded that yesterday. So I know it's kind of a little bit late, but better late than never. So it's uploaded. A few of you had some issues uploading some of your stuff to Lima. For whatever reason. I'm going to make another file that will allow you guys, during the time that we're doing class and I'm lecturing, I'll do another file that will allow you guys to upload into another file. I don't know what would happen with those two, but for some reason I've had, it's 3 people or 2 people that said that they had some bounces. I don't know why. Everybody else seems to be fine, but we need to make sure that we accommodate everybody. Couple things that I just want to mention that are coming up. Timeline from where we're at. So moving forward, the last day of class or a final will be on Thursday. It will be on the quizzes online, and I will launch that so you don't have to log in on Thursday. It'll simply just be our final, and you can take the final, log in, take the final, and I will be online on Zoom. That way, if you do have questions, you could Zoom me and say, hey, Chris, wait a minute, I'm having problems with this, and let me know, right? Like I think there's one thing on there that some people see it as blurry, other people have it completely fine. So if you get that one, because the test is randomized, so everybody gets a different test, you can then Zoom me and say, hey, Chris, I don't have this, and I can send the file to you right away. Or if you have a question on what it is that the question's asking, you can also Zoom me for that. So that's on Thursday. On Wednesday, we have our class, and then after class, so we'll have our class, everybody can go to lunch, hang out for a bit, and then we're going to do something called boot camp. And so that boot camp is going to take up a tremendous amount of time. Okay? I'm here to teach you from the beginning of what we first learned all the way through the end. Right. Questions on that? We'll do that on Zoom. We will also do that will be on Wednesday. We'll also do that to where you can come into campus, and those of you that want to be here live, come on down. Okay. Come on down, and we can do that live. Questions on that? So as of, I believe it was Saturday, all of your assignments were graded on Saturday. Now, if you submitted something Sunday, I haven't got to it yet because it's after I did the last grading, but everything that was submitted up till then, one person finished problem set 4, and I haven't graded those yet. I was just waiting for more people to submit. That way I can start grading it. We haven't gotten all the way through the material, just in case that person submitted it prematurely and did it wrong and wants to resubmit. I just figured that I'd get through all the material. Okay. Also, we have the ethics case, and I know that's coming up. The ethics case, you click on the assignment that says ethics case, and it will show you a Harvard business case. The Harvard business case is the use and misuse of statistics. That's by Francis Fry. He mentions 5 different areas that you need to be careful with. 5. And when you write up your ethics report, I want you to address 5 areas. It's worth 5 points. If you mention 1 area, you get 1 point. If you mention 2 areas, you get 2 points. I keep on going with this. You get it though. If you mention 4, you're going to get 4. And you're like, why did I get 4? Because you didn't mention all the areas that you need to be concerned with. So I just want you to talk about it. And the easiest way to do it is say, articles about Francis Fry, misuse of statistics. These are the different areas that he talks about, and just put headings for 4, and then talk all about 5, and talk about the 5, and then hit submit. Right? There's also an extra credit paper that we'll have that I launched, and it's called the Joy of Stats from a guy in Sweden named Hans Rosling. And so you watch that, you write up a little short paper on it, there's instructions for that, you can get extra credit for that. The quizzes are all I just want to make sure that I say this, extra credit. All of the quizzes are extra credit. Okay? Just want to make sure we're clear about that. I know on chapter 13, some of the fill in the blanks, it doesn't grade right. I get it. That's why it's extra credit. And on the very first day, I'm not sure if you remember this, but I tell you that when the class is over, when I start compiling the extra credit, what I do is I give you 1 extra credit point for the misgrading for the quizzes. And so after doing this for 10 years, we've figured out what's the average amount it's off by, and it's never off by more than 1 point. So I just give you the 1 point, regardless if you're doing the quizzes or not. That way we don't have to go back and forth like, oh, I got this right, can you do that? I just give you the point, right? And that way we can make sure that it's fixed. You can hand in 2 late assignments and not get dinged very much. So if there's some assignments that you haven't done, please turn it in. If you turned in an assignment, you didn't get full credit and you want more credit, fix them and resubmit. And I've had that a lot. One of the ones where there's quite a few people that have messed up on it is with the descriptive statistics, and I believe that's problem set 1. And so with problem set 1, where we unstack data, it's either 1 or 2, I believe it's problem set 1, where we unstack data and we are looking at risk and a fee, and the other one is cap size and returns or whatever it was. But you unstack those 2 datas and you have descriptive statistics that will say like shape of the data, variability, and central tendency. And what I want you to do is to speak about that and what you're seeing in the data. You say, oh, looking at risk, it looks at, or looking at, if they paid a fee and how much money they made, it looks like the people that didn't pay a fee actually made more money than people that paid a fee. The ones that didn't pay a fee, they made $8, $9. The ones that paid a fee made $8, right? And looking at the median, that's for the mean. Looking at the median, it's this number, and there is a motive or not. Looking at variability, it looks like the average amount that they differed from that $8 or whatever was $3 or $10. The coefficient of variation tells us that they differed by about 10% or 8% or 30%, whatever it is, right? The coefficient of variation for this one was this one, but what I want you to do for each one of those, for those 2 data that you unstacked, so you unstack the data, I want you to write 3 paragraphs. 1 paragraph with central tendency, 1 paragraph with variability, and 1 paragraph with shape. This, of course, is the mean, the median, and the mode. Variability is a standard deviation, coefficient of variation, IQR. Shape is skewness and kurtosis. And I want you to write a paragraph, and it could just be a couple sentences for a paragraph, right? But for both of the ones that you unstacked. And so a lot of the times what somebody will do is just to write it for just one. They'll write it for fee and income one, but they may not do it for the one that has to do with risk and income or whatever it was, because you also have some for that too. And so if you're in that category, please just fix it, resubmit it. Right? It's not like I want to disenfranchise you. No, you do the work, I give you the points. Just that simple. Okay. So the last day to submit homework, the last day to submit any homework, no matter if it is a redo or if it is just your homework, is this Wednesday. The last day of class is Thursday. So class ends actually Wednesday midnight, and the only thing that we do is we take a final after that. And so what I'm trying to do is to make sure that you realize that that cutoff day is Wednesday midnight. Okay, Wednesday at midnight. All of you for every assignment are supposed to submit it. I know that maybe you work in a group, and one of your group members submitted theirs, okay, that gets them points. Make sure that you're submitting yours as well. And I know that I say this over and over and over. Just want to make sure that I'm clear about it. Any questions on any of that? Okay. So again, today what we're going to do is we're going to have a guest speaker. Tomorrow we're going to have a guest speaker as well. Today our guest speaker will be a girl named Wysam. She'll speak with us a little bit. She actually works for a company called PricewaterhouseCoopers. She's from the Big Four. She does international trade or international business. She'll speak with us for a few minutes. I know that she has another phone call that's coming up in just a few minutes, so she's going to run out of time here really quickly. But she'll be able to speak with you, and you'll be able to speak with a professional. She's somebody that's just a couple of years older than you. She graduated from the Chandler College of Business School. After graduating, and she will fill you on some of those details. Okay? But without further ado, let's give it up here for Wysam. Say something, Wysam, so I can see.
Hi, I'm Wysam. Can you see me? Can you hear me?
Say it again, so I can see.
Hello.
Okay, I think they can hear you. Can you guys hear her? Somebody give me a thumbs up. Okay.
Yeah, we can hear you.
Awesome. Thanks. Times have changed. My company actually doesn't use Zoom. I've been using Google for the past few months. I just downloaded Zoom for this call, so bear with me. I'm trying to get up to speed with technology. But thanks so much, Chris. Can I speak now, or did you have anything more to say?
Come on, bring it, girl.
Awesome. Well, thank you everyone for your time. I'm sure, how many weeks have you been in class already? Like 4? Oh, wow, okay. So I took Chris's class. I want to say not too long ago, but it has been a few years since I took stats with Chris in good old Scheidler, one of the E buildings there. But I graduated not too long ago from UH, Scheidler College of Business. I was an international business major, finance major, and I also did a major in the English department as well, because I like to read and write, and that makes sense further along in a couple of minutes. I'm sure you guys are all here because you guys hopefully will be graduating soon in a couple years with a business degree. When I took Business 310, I was actually a sophomore. I had entered Scheidler through the direct admit program. But other than that, I would say my experience in Scheidler is more or less very similar to yours. I chose international business because I wasn't really sure what I wanted to do, but I did have a couple of goals in mind. I was interested in finance, more so in economics at the time. But I wanted to major in business because I went to UH. But also I was very impressed by all the international opportunities that UH and Scheidler had, which I felt were very unique, not just in Hawaii, but in the US overall. Because I had wanted to go to mainland college, but I decided to stay home. And this is relevant eventually because my career now is in international business. I never realized at the time going to UH, I was very focused on finance. If you guys are taking Business 310 at this point, maybe next year or in a couple years, there will be an opportunity for you to, if you're interested in finance, as I was a part of the Certified Financial Analyst program when I was a junior. At my time in Scheidler, my mentor at the time was Ben Bystrom, Professor Bystrom, and he's led a project for me where we had a client and we did a lot of valuation analyses, just like what they do on Wall Street. And to that end, I did not realize that at the time when I was taking Business 310, but the skills that Chris is teaching you is very relevant, and not, it might not be obvious at first, but Chris's class was the first time where I saw a problem set as more than just math problems. These were problem sets where it's similar in a way to what you would get in the real world, where you have a portfolio of client data. And the key thing about data is, I'm sure you've heard the difference between what data is and what information is. There is a translation that's necessary to sort of paint a narrative using data and translate that into information that clients and your professors and eventually you can use, because you can't really use data. Everyone can have data. We're overflowing with information, well, data, I should say. But in order to really make use of that is to utilize the concepts that you'll be learning in Biz 301. If you're an accounting major, the accounting concepts, the financial concepts, management, marketing, think of all these skills as tools that you can use to translate these massive data sets in a way that you'll be getting in the form of problem sets and other ways in bite-sized scenarios that you'll be getting in class, but translating that into information that you can use and present and really make sense and in the real world. And honestly, I say the real world, but we're all living in the real world now. A little bit of my background, tying all these pieces together. I was a finance major, working international business now, specifically customs and international trade. I will say the Scheidler class that is most akin to what I'm doing now is Business 311, which I believe is international economics, if that's still one of the core classes that's required. At the time, I had Professor Jack Siderhout, but I've heard he's retired since then, so it's been a while since I've been at Scheidler. I believe you've heard from a guest speaker previously, Matt, who's a lawyer. He, from what I remember from our conversations from Chris, he is now working in finance, but he probably didn't do finance when he was in school. So it's okay if you don't know what you're doing, or it's okay if you do know what you're doing and you end up doing something entirely different. In my case, when I took Business 310, I thought for sure I was going to do something that was economics related or financial analyst related. I thought I was going to work in a bank doing compliance or some sort of financial analyst. I know, very not the greatest, not the most exciting, but at the time I thought it was pretty exciting, coming off of the financial crisis. But I actually went to law school, which explains why the English came in. I was lucky enough while I was at UH to have the opportunity to both refine my financial and mathematical analysis skills and business acumen, because I was at Scheidler. Had lots of very amazing mentors at the time, including Chris himself, with various backgrounds. But I was also able to marry that type of knowledge, that type of interest with my interest in literature and writing. And one of my favorite classes was business law. Then I went to law school and I realized law school is nothing like business law. But for those of you who are interested in law school and beyond, I'm happy to answer more of your questions. I am running out of time. I do have a few minutes, but it's been interesting in that I was so sure I was going to do banking. and something financial, maybe even investment banking related, commercial banking. Ended up going to law school. Um, Thought I was going to work for the government. But I was also, I remained very influenced by my time at Scheidler. When I went to law school, I went to law school in DC. Well, technically Arlington, Virginia, but I interned for about 6 semesters, not including a summer, in DC for various federal agencies. And I was very interested, particularly in the area of financial regulation. And so that is one of the ways where I saw the intersectionality of what I learned in Scheidler, my passion for public policy, or at least my interest in it, as well as my personal strengths in research and writing. So I really do encourage you, while your time at UH and Scheidler in college, to really see what interests you, what you feel are your strengths are, and play to that. And it's okay if you don't know what you're interested in. Um, and it's okay if you decide further down the line that what you thought you were interested in isn't what you want, ended up, maybe that's not what you really want to do. And it's okay if you find your way back. So in a way, I kind of found my way back to business, um, in albeit in a different manner. Um, I in this economy, um, I will be honest. A lot of my friends are currently not working, or they have to work less hours, or they're being not laid off, but they're being furloughed. Even some of my friends in pretty prominent law firms. I am currently very fortunate because I am in customs and international trade, and we cannot find enough people to work in my area because of our president and everything that's going on between China, the United States. Everyone needs to import, export. There are a lot of laws that each country upholds, and as as um, as globalization manifests, we have a lot more multinational companies, and which means a lot more laws and regulations and compliance issues that these companies need to be mindful of. And so, in a way, I was able to marry my business acumen skills, data analysis skills, which a lot of lawyers did not have, but I did, thanks to my time in business school. But I was also able to be curious and be mindful of my different audiences. And so if I spoke to business people, I wrote my emails differently. If I knew I was speaking with a lawyer, my language would reflect that as well. And so I really have a lot to be thankful for with my time at UH, uh, giving me that sense of empathy and diversity of skills, really. I feel like I had a really diverse education, and the course offerings I was able to take while at UH, and I never stopped asking questions, and stay curious, and what you might find, discover about yourself and where your interests are might surprise you. So that has led me from Honolulu to DC. My international business major has led me to 2 study abroads in Shanghai, China, and Germany. And now I am in New York in the middle of the pandemic, which wasn't great, but I've been home. I've been working from home for 3 months. But hopefully I'm still sane. Hopefully you all understood me, with me blabbering for about 10 minutes or so. But if you have any questions about what I just said, about your life, your interests, please let Chris know. I'm happy to connect with any of you. All right.
Does anybody have, and I know she's got to go like in 2 minutes. She's got to go.
I have a 5-minute grace period. I let my supervisor know.
She's currently at PricewaterhouseCoopers.
Oh, sorry, PricewaterhouseCoopers.
PricewaterhouseCoopers.
Yeah.
The PricewaterhouseCoopers in New York. And anybody have any questions for her? You can interact. And she's, like I said, she's just a couple years older than you guys. And I hate to ask this.
I hope so.
About 25 now?
26, just turned 26.
Oh my God, you're old. 26.
I know.
Right? So working out of New York, PricewaterhouseCoopers, sorry, I bet.
PwC, one of the big four. They don't all just do accounting. So if you're interested in some of these non-conventional career paths, I'm all about those.
So we may also, Alessa, we may have them speak with Alessa too. We're trying to see if we have time, but tomorrow definitely with Winnie from Twitter, right? But Alessa, well, we'll see. She's also killing it too, and she's now with you guys as well. And so it's funny because I remember Wysam when she was your age, sitting in my classroom, and so we've actually built her up to this monster that she is. But you guys ask some questions. Enough of me talking. Do your thing. Anybody have some questions for Wysam? I see you there, Caitlin, with that look on your face, and you're like, maybe I have something. Do you have a question for her?
No, I can't think of any right now.
How about you, Lauren?
Does the job you currently have require law school education, or did it just happen to work out that way?
It just happened to work out that way. We have, well, the big four, they prefer you to have a credential. And so I'm actually in the tax, like the larger tax department, because customs and duties is a form of indirect tax. For you guys, for your accounting majors, you'll know what I'm talking about. But one of the credentials that they prefer is a bar, a JD, or actually a license. It's actually not required. A JD is not required, but it helps your career trajectory if you're able to enter the firm with either a CPA, in my case, a customs broker license, because I'm in customs, or a bar degree. Oh, sorry, a bar license. So I'm barred in the state, in the state of DC. Sorry, in DC. I took the DC bar.
Gotcha. Thank you.
Mm-hmm. No problem.
How about you, Edna? We got some questions? How about you, Karsten? You have any questions for Wysam?
Not really. She went through everything pretty well, I feel like.
Okay.
Got a lot of information from it. Thank you.
Okay, good. How about you, Nora? Rose?
I don't have any.
Rose? How about you, Susanna? Well, I think, so if anybody that I haven't spoke, if you have a question, just kind of tag in here. How about you, Kelly Do?
I don't have any right now.
Okay. All right, well, I guess I don't have any questions here, Wysam. So we want to thank you for your 1 minute over, for spending some
No
of
worries.
the late, great New York. Stay safe out there, because I know it's a little bit dangerous. I have quite a few friends out there. If anybody does route any questions, route them to you, okay?
All right, that sounds great.
Thank you. So here in Hawaii, we say aloha.
Aloha.
I will talk to you another time. Thank you so much, okay?
Yes, Chris. Well, thanks, everyone. Have a great day.
Thank you.
Bye.
Bye, guys. Bye. Okay, now let's get moving here. Oops. what's going on here? Speaker view. Exit. Speaker view. Okay, let's get moving. So what we're going to do now is we're going to go through our PowerPoint presentation. That way I can put some of this stuff together on paper so you can see how it works out, because I like to draw stuff on the board. I like to get us to understand what it looks like, you know, when we're putting it together. I like to really focus on what all this stuff means. But then I also have these PowerPoint presentations that will actually, that are put together to further explain and to further help you to kind of get it. And so what we're gonna do today is we're gonna go through these PowerPoint presentations. I'm gonna break them down for you, what it is that we're doing. And then tomorrow, all day tomorrow, we are going to work on our homework assignment. We're gonna work on understanding what the heck this means, how to apply it. And tomorrow will be Tuesday. We will do that on Wednesday again. Tomorrow on Tuesday, we're going to be speaking with, and I like bringing people that are close to your age to where you can see like this. I'm not intimidated by strong women or by people that are younger, that are stronger, that they're on the uprise. I celebrate and I want to push them forward and help them to get where they're trying to get. And so I like it when I can actually take somebody that's 1 or 2 years older than you. That's just killing it out there, right? Making like $20,000, $30,000, $40,000, right? A month, sorry, not a year, a month. And I like bringing people to you that are that successful, that were in your position. Why, Sam? A few years ago, I mean, she was really timid. And we built her to some very strong person now, right? She gets into a room and doesn't back down for anything. And so I love that. I built that. And so let's now start with our PowerPoint presentation. So Lauren, give me a thumbs up if you can see that. You can't see it. Okay.
Now I can.
Okay, good. Good, good, good. Can you still see it or no? Hello?
Yes, I can.
Okay. Now I can't see you guys. I don't know why. Can we still see that? Yes? Somebody help me.
Yes.
Okay, good. Sorry, because sometimes I'll change like the views on my computer and sometimes I know it goes off. So in this chapter, we're going to learn how to develop, right, a multiple regression model, how to interpret what's going on in the model, and also if something goes wrong with it, how we can fix it. And so when we're looking at the model, again, like we had before, so when we're looking at the model, we had our dependent variable and how our dependent variable moves, or what's a result based off of our intercept, based off of our different slopes and our standard error. And so what we learned in simple regression is what would a house be worth, or how much money would we make based off of so much money per square foot of shelf space and how many feet of shelf space we had based off of the intercept. And our why was like, how do we make revenue? How do we figure out how much revenue we could actually make from that? And so we figured that out. And at the very end, we said, well, our model's not perfect. So this number that we solved for, that we're going to make 432,000 or whatever it was, that's going to be off roughly by about $40,000 or $30,000, whatever that is. And that's what this model is showing us. So the y is our dependent variable. We're trying to figure out revenue, cost, whatever it is, based off of our intercept, which is B0 plus B1, B2, those are our slopes, and based off of error, how much error do we have in our model? So our standard deviation, how much that's going to be off, and that's what our model is. So our equation, even though it's still like this, is when we take our model and we actually plug numbers into it. And so we're going to learn how to do that. So here we're looking at two independent variables. So we're looking at pie sales and we're looking at price and advertising. And we have data and we're trying to figure out, is there some type of slope involved here? So here we're looking at our pie sales, 15 weeks. We're looking at our price and how much advertising we do. And we notice that advertising is in hundreds of dollars. So the most advertising that we do is $450. And the highest price we've charged is, what's that, $8. So when we start doing our forecasts, we can't plug in any numbers higher than $8 or advertising more than $450, because that'd be going beyond what we actually have data to prove. So if we run our multiple regression model, and I'm going to show you how to run this in PHStat. I'm also going to show you how to run this in Excel, because those of you that your PHStat's having problems, if I show you in Excel, it's just as easy, just off your basic Excel, and it's just as good. The only thing that we're going to miss is our Durbin-Watson, but I'll show you how to get around that. And so when we're looking at our regression and we're looking at putting together an equation, and we have y is our sales equals B0, which is our intercept. So it goes B0, intercept, B1, price, B2, advertising. So 0, 1, and 2. So our sales is based off of our intercept, 306 pies. For every dollar that we raise the price, we sell 24 less units. And for every $100 that we do in advertising, we sell 74 more pies. And this is going to be off by roughly 47 pies. So if we start putting numbers here, we can figure out that whatever we solve for is going to be off by 47 pies. I'm going to cover some of this stuff, even though we're looking at the slide. I just want to make sure that we can pull it all together on this slide. So this multiple R, even though for multiple regression we're a little bit cautious with the multiple R, it tells us how strongly related is price, advertising, and sales. How strongly correlated are they? And this tells us about 72%. Multiple R is R. If you take R and square it, you get R squared. That's what this is. R squared tells us 52% of the increase or the decrease in our sales are due to the increase or decrease in price or advertising, which tells me that if I do more advertising, I'm going to increase sales. If I raise my price, I'm going to decrease the amount of sales I do. And that's what it's telling us. So the increase or decrease in price or advertising will increase or decrease our sales. And it also tells us that 52% of our sales have to do with the increase or decrease of these, which then tells us if only 52% of our sales are because of price and advertising, that means 48% is due to something else. That's a lot. We're missing a variable here. There's something here that we're not getting a full picture. So our model here is not that strong. Only 52% of our sales has to do with that. Right here, our adjusted R square is our R square after adjusting for these slopes, for price and advertising, and for 15 observations. So it's a more conservative one, and it's typically the one that most people go with. So we can only account for 44% of our income, right? Or 52% of our income, which isn't good, which means that this model is not very strong. But what allows us to use a model that's not that strong is our standard error. That allows us to use this not so strong model and be able to be pretty confident in it. So if you're putting together a budget based off of a model like this, you would look at your standard error and you would say, we need to pad our budget by 40, if it's in thousands of dollars or hundreds of dollars, 4,700, 47,000, it allows you to realize how much you have to pad your budget by. That's what that standard error allows us to do, is to take a model not that strong and use it. And that's why that Durbin-Watson is important, because that actually tells us how good this standard error is. So if we have a crappy model and it only tells us 52% of our sales, and if our Durbin-Watson's no good and our standard error is no good, this model is really a bust, right? We find ourselves in trouble. Okay. What the significant F is our p-value for the model. And when we look at our coefficients, our intercept as if we charge, if everything else was zero, if zero price and no advertising, we would sell or move 306 pies. Our standard error tells us how much that intercept is off by, 114 pies. And if we, so that's kind of like our standard deviation for the model. And then we have a t-test to actually tell us if it's a slope or not. But because it's an intercept, there is no slope to it, it's a starting point. This lower 95 and upper 95 is our confidence interval. 95% of the time, our intercept will be anywhere between 57 to 555. That's what it's telling us. And how do we derive this? Remember, if we look at our empirical rules, we have one standard deviation is 68%, two standard deviations is 95%. So we take our mean and our standard deviation. This times 2, added to that gives us that. This times 2, subtracted from that gives us that. And that's how we derive that. Looking at our price, it tells us for every dollar we raise the price of our pies, we're going to sell, I'm going to round that 24.9 to 25. We're going to sell 25 less pies for every dollar we raise the price. Give or take 10 pies. This right here, our t-stat and our p-value is going to tell us if we actually have a slope or not. So if that p-value is below our level of significance, we actually have a slope. And this tells us, that price, how much, 95% of the time, we will sell. And that's anywhere from a negative, for every dollar that we raise the price, a negative 48 to a negative 1. That number right there is just right in the middle. Advertising tells us, for every $100 of advertising we do, that's how many more pies we sell. Give or take 25. And that tells us that p-value if we actually have a slope or not. We're going to notice that as we add in another variable, remember how I said before that when you have all these different slopes and you're trying to come up with an intercept, how it changes the value of the slope? We're going to find out later on when we add in holiday that price in advertising no longer becomes slopes. And so it's going to be an issue. And we'll look at that and even how to fix that. So multiple regression equation, here it is, that our sales equals our intercept of 306 plus V1 price times whatever that value is at X. How many dollars are we going to charge? Plus 74, an extra 74 pies for how much advertising we do, and we need to put a number in there for advertising. How much advertising? Then we can solve for how many pies we're going to sell. Okay. So if we wanted to predict for a week at $5.50 with $350 worth of advertising, we can solve for that. So here's our equation, 306 plus this. We plug in 550 there and 350 there. And so we multiply this times that, and add them all together. And after we do that, we find out that we were going to roughly sell about 428 pies. Okay? 428 pies. So we can run this with our multiple regression. You want to click this right here. So here's also something else that I want to, and I'm going to say it twice. For those of you that are like sleeping a little bit, or you're eating a peanut butter and jelly sandwich or Doritos or something, put it down for a second because I want you to hear this. Because when you're running your model, you're running into this. Some of you are running this model in PHStat, and as you run it, you're having an error message and your confidence interval prediction thing is not working. What happens is one of our variables that we're looking at is categorical, so it has an issue. So what I want you to do is to run your regression model and only click, regression statistics to table. You don't have to click this, but click this. Only the first and the last one, and put in the 95%, and it will bring up this thing and allow it to work. Okay. So when we're looking at this, the price given is $5.50, $350 worth of advertising. It gives us 420. Okay. So looking at this is our confidence interval where we're not using the means of the variables. Right here, we're predicting confidence interval based off of this prediction. So what's our confidence interval based off of this prediction and our error in the prediction? And so this tells us that that's our number, and based off of that, it's anywhere. So right here is telling us based off of this price, we should sell 428 pies, and this tells us that it can be anywhere from 318 to 536. This right here is not necessarily, this is a confidence interval, but not necessarily based on a prediction. If you notice, the confidence interval right here, because this is adding error into it, is larger than this one. This one goes down to 391 to 466. This one goes all the way down to 318 to 538. So this is adding more error in it. Okay. So our R-square is telling us 52% of the variation in pie sales, either the increase or decrease in the pie sales, is explained by increasing the price or decreasing the price, or increasing advertising and decreasing advertising. Our adjusted R-square is our R-square. Our R-square, when adjusting it for the amount of variables that we have, so our slopes, and it's also adding it in for our sample size as well. Okay. That's our adjusted R-square, and it's telling us that 44.2% of the variation in pie sales is explained by the variation in price and advertising, taking into account the sample size of 15 and the number of independent variables. Okay. So is our model significant, right? Is whatever we're predicting, like, is this good or not? So we can test this, right? So one thing we want to find out, we want to write a hypothesis, like, is this even regression? And this is our p-value to know if we have a regression. So what we first do is we write up our hypothesis saying, hey, right, and we do it B1 equals B2 equals 0, no linear relationship, or at least one of the B's does not have a 0. And we look at our p-value, and if it's below our level of significance, we can reject that null hypothesis. And after we do that, what we want to find out is, okay, so we're saying that at least one of them has a slope. We want to find out which one has a slope. So then we write up a hypothesis for price and advertising to see if one of them has a slope or if both of them have a slope. Okay. This right here is our confidence interval, 95% of the time. This is how much our price will be adjusted, right? For every dollar that we raise it, be anywhere from a negative 48 less pies to 1. That's kind of that part of the chapter. What I'm going to do is I'm going to stop sharing that, and I'm going to go to another one because I want to get into Lauren, give me a thumbs up if you can see this. Okay, good. So we have something that's called a dummy variable. The heck is that? And so remember when we looked at data before, we wanted to break it into categorical or numerical. Numerical are numbers, categoricals are names. And for most of the model, the t-test was numerical. We're comparing means against each other. The ANOVA, numerical. The z-test, categorical. The chi-square, categorical. Well, guess what we're going to be able to do now in the regression model? We are going to be able to add a categorical variable to our model. So we can actually use a categorical variable in here. And we're going to code it 1 or 0. And so if we're looking at like sales, maybe we look at the people that buy stuff in our store. We can say, are they from out of town? What income bracket are they in? Because perhaps they buy or don't buy more. And then are they male or female? And perhaps if they're a female, they buy more products, or if they're male, maybe in certain stores, they buy more products than females. And so we can test that. Also, like, are they a tourist versus somebody that lives here on the island? And perhaps a tourist will buy more stuff. If you're looking at Dole Pineapple Plantation, when the tourists go in there, they buy more stuff than maybe a local person, right? A local person goes in there to buy a cup of coffee, get some Dole Whip, and then split. Maybe a tourist will buy hand soap and plates and all kinds of stuff. But so you're able to code a categorical variable and add it to your model. And so if we wanted to add in a holiday, if a holiday occurs or we had a sale, do we make more money? And we code it 1 or 0, right? We're going to code the holiday either 1 or 0. So here, if we're looking at our data again, here we have our pie sales, the price, the advertising, and we're looking at this, and on this day, no holiday occurred. On this day, a holiday occurred. A holiday occurred, and all of them that has 1. And so what we could do is we can actually add holiday to our model. And we can see as we run this model, and it tells us if our holiday actually occurred or not. Okay, so we added, so in this model we ran price and holiday, right? We didn't run an advertising in there. And so when we're looking at price and advertising, it tells, price and holiday, it tells us if a holiday occurs, we actually sell 110 more pies. Right? If a holiday occurs, we sell 110 more pies. We notice that when we look at our adjusted R-square, it's going to change because the amount of variables, right, in their sample size. But so we can see if there's an impact by adding this, because our adjusted R-square would get better. Right? We can see if there's an impact by looking at this. But we also notice that, remember before where our price was okay? Look at our slope for price now, it's actually no good. Right? It's not below 0.5. So it actually hurt us by adding this. But there's a way to fix it. So an interaction between independent variables and what that means. I'm going to turn this off for a second. I'm going to jump on my pulpit here, and I'm going to talk about this for just a second. Okay? So, what does interaction mean? Do you know? Let me see. Are you there, Edna? Edna? Did we lose Edna? Okay. All right, Elisa. What is do you know what the word synergy means?
I've heard it. I don't know how well I could define it, but what comes to mind when I think of something that's synergist is like things that work together well.
Yeah, that's pretty close. What most people say synergy is synchronized energy, where you just have two of these things of energy that get together, and because they're able to synchronize, the two things together make up something that neither of them by themselves would be able to do. Here's one example. You take some dirt out of the ground, you mix it with some water, and you heat it up, and you can actually make some clay, adobe clay or something, and actually make a house out of it. So you take these two things, dirt by itself, which I'm not going to say if it has a lot of value or not, because it is our planet and we actually live on it, but I'm just going to say by itself, it's just dirt. You have water, which I guess is okay because we do a lot of stuff with the water, but you mix them together and they make something that by themselves, neither of them would be. So here's another example when we look at business-wise for what synergy would be. And I know every time you go to a business meeting, they're always saying, and perhaps we can get some synergy if we make these two things. And you're sitting there thinking, oh my God, I wish I could throw my shoe at this person, but you can't. So here's an example of synergy. So imagine if we didn't have COVID and you went to the mall and all of a sudden you see this advertisement at the mall and it says, Macy's, we just got new carpet, come in and check it out. And you're like, okay. And so they do advertising, they do a lot of advertising, but unfortunately you're just like, okay, they got new carpet, big deal. And then another time you go to the mall and you're there hanging out with your friends and they're all like, dude, we're gonna go to Lucky Strike and play some video games. And you're just like, kind of into it. They go to Lucky Strike, they're playing some video games and you're like, I'm just gonna go over to Macy's and check out the shoe department. And so imagine you just walk in there and all of a sudden you get in the shoe department and it's like, dude, 80% off all the shoes and they're only gonna do this for 3 hours. And you're just like, what? You look on your phone, you look at their whatever, your Macy's app, I'm not sure if they have one of those, and you don't see anything. You're like, how did they do 80% off of all the shoes, not just the crappy ones, but all the shoes, and they don't advertise it? And imagine the general manager is saying, you know, we had a shoe sale, we had 80% off, and we didn't have any more sales than we normally do. Well, guess what? If you do advertising, like come in and look at the carpet, and if you do a sale and you don't advertise it, perhaps sales aren't going to increase. But what would happen? Would you get some synchronized energy here if you lowered the price 80% off and you advertised together? Probably. And so when we're looking at an interaction, if you look at sometimes these slopes in regression, you'll notice that you have one slope and it's not quite a slope, and you have something else and it's not quite a slope. So imagine if we're looking at, they put out an ad and they're looking at the amount of sales in the store, and they put out this ad and it says, come look at our carpet. You look at that slope, did sales go up? Nothing. And then all of a sudden you had something else where you're looking at sales and they decrease the price of shoes, but they don't do any advertising. It's just like somebody just goes out there and they don't even put signs up, right? You go there, there's not even a sign that says everything's 80% off, nothing. You're just looking at the shoes and then all of a sudden you're like, oh, well, this is neat. I always like these. And like, 80% off. And you're like, how come there's no signs? How come nobody advertised it? There's nothing. And all of a sudden you find out that it's not increasing. But what would happen if you combine those together? So what we're going to do in this is we're going to combine all the data. So when you look at the data for advertising and you look at the data for price, imagine if you combine those two together, you make a new slope. So if you have one Excel spreadsheet row that says B1 and the other one says B2, on B3 you're going to say B3 equals B1 times B3, and you're just going to multiply those together. By multiplying those together, you create another one. I'm going to call, price and advertising PA, right? So you're going to combine those, and perhaps by combining them, they actually make a slope together. And I know it seems kind of a weird way of doing it, but it works. It really works. Okay, let me go back to this again. Go to 16. Oops, that's that one. 17. Okay, so that's what our interaction is. So with our interaction, what we're going to do is we are going to combine. We're going to take two of them and we're going to combine them together. See where we have B0, B1, B2, B3 is like X1 and X2. We're going to combine these two together. And by combining them together, we're then going to rerun it. And after we rerun it, we want to see, is there some type of an effect with this interaction, right? So do we have to check linearity? So right here, some people say like, don't check linearity. I like to check it, but some people say don't check it, just put them together, right? What they like to do is, instead of that, what they want to do is they want to check our R-squared to see if our R-squared actually gets better, right? So in some of these, they won't check linearity. So here you have holiday and advertising. And we want to see, we want to go back later on and we want to check these, right? And so we want to take a look at our adjusted R-squared, right? We're about 85% confident that holiday interacts. Note the adjusted R-squared is higher with the interaction term. So we want to look at our adjusted R-squared and make sure that it actually got better. And if it does, then we can use this. Even though this p-value is kind of like not necessarily good, but then we end up with something else that we have to worry about, which is called multicollinearity. And we'll cover that in just a second, right? Multicollinearity, like what is that? Okay, so we're looking at when you start to adjust things, what it actually does. And so what is multicollinearity? Remember when I told you guys when we were doing the, on chapter 5, and we were looking at these cards, and it's like, what's the probability of pull ace out? What's the probability of pull red ace out? And we had one of those slides that said, what's the probability of pull a red ace out or an ace? And so when we looked at that, what's the probability, sorry, that you'll pull a red card out? What's the probability that you'll pull a red card out of the deck or you'll pull an ace out of the deck? And when we looked at that, the probability you would pull an ace is 4 out of 52. And the probability of pull a red card out is 2 out of 52. And so when we combine those to figure out the probability, it ended up being 6 out of 52. And then you divide that and you get a number. But remember that slide that I told you to take a picture of? Look at that slide right now if you took a picture of it. If you didn't, just kind of go with this. And I told you if you didn't take a picture, later on you're going to go, oh my God, I should have done this, but whatever. So here, if we try to figure out this probability, there's actually 6 out of 52, and we're double counting it because there ain't 6 cards in the deck. There's only 4. So what we had to do was we had to remove 2 out of 52, which then gave us 4 out of 52, right? It's because we're counting some cards twice. Here we're counting 2 red aces, and right here we're counting 4 aces. So when we add them together, there's 6 aces. So we were double counting. That's known as multicollinearity. It's when you are counting something more than once, and you're actually inflating the value. You're actually inflating the value. And so you have to be a little bit careful with inflating the value because your end result's going to be bad. What does that mean for us with multiple regression? So imagine we're looking at a house, and with the house, we're looking at the value of the house. And so we create a slope like this, and we're looking at how much a house costs. And so the slopes that we're going to look at is one of them, we're going to write square feet. The other one, maybe like how many bedrooms it has. The other thing maybe we're going to look at is location. Right? The other thing we're going to look at, because believe it or not, bedrooms are great. And a lot of people spend a lot of time in the bedroom, but also in other parts of the house too. And so some people are like, oh my God, I'd love to have a big bedroom. Other people are like, I'd love to have a big kitchen. I'd love to have a really nice bathroom too, because you don't spend a lot of time in the bathroom, but a lot of the times people spend a lot of the money on the bathroom and the kitchen. So when you go into a house to buy it, you look at the bedrooms and like, okay, this is okay, but the bedroom is pretty much 4 walls. You put everything else you want in it, you want it a certain size. And if it came to like, do you want a big family room or a big bedroom or a big bathroom? Who knows? But perhaps some people are really into like, okay, I want to have a big bedroom, or I want to have a big family room. So you start looking at, okay, I want to see the size of the kitchen, because that's important to you. So you want to see the size of the kitchen, and based off of the size of the kitchen, and maybe even the size of the rooms, because you don't want small rooms. And so you're going to have to, so all of these, so you have 1, 2, 3, 4, 5. So you have, you know, beta 1, beta 2, beta 3, beta 4, and then beta 5. And then of course you have to come up with an intercept for all those, wherever that goes. Right? And then based off of that, you can come up with how this increases the value of a house. Well, guess what happens here? This is one of those things where I want to, if those of you that are sleeping, I want you to wake up for just a second, because this is kind of important, okay? Those of you, can we do a couple of these, right? So if you guys are awake, put your right hand in, put your right hand down, put your right hand in, and shake it all about. Do the hokey pokey and turn yourself around. This is what it's all about, right? Sorry, I have to be goofy like that because that's just me. But if you're not like that, I'm cool with that too. So I do goofy stuff like this. Why? I don't know, but anyway, just that way you won't get in this glazed over thing where you're just sitting here like, oh my God, I'm looking at this screen. It's driving me crazy. Later on, when you see me on campus, you can throw your shoe at me. Just give me the heads up. That way it doesn't hit me. I don't know, so I can talk or something. But if we're looking at the square feet of the house, and as the square feet increases, the price of the house, how about the size of the kitchen? If we say, okay, the house is like 4,000 square feet, and we say, oh, the kitchen is 500 square feet, so we add value because of the size of the kitchen, aren't we already counting for that right now? Aren't we already accounting for that in the square feet? Just like we did with the deck of cards? So what we're doing is we're counting feet twice for the value of this product, and we can't do that. We can't do that, right? We can't do that. We can't double count things because we can inflate it. It's almost like if we were looking at costs, so I'm going to go to costs here, and we're looking at the cost of maintenance for, like if you run a business, you know, like how much does it cost us to maintain this business? So you look at what the maintenance department charges you. And perhaps in there is all the supplies and the hours of the employees. And so you forecast that with the cost of the maintenance, and then you also look at, oh, wait a minute, how much are we paying in salaries? Because you also want to see how much it's costing you. Well, guess what? You're accounting for all the salaries already, and then now you're saying, how much does the maintenance department alone cost us? So you're double counting those salaries. And so when you forecast how much it's going to cost you, those numbers are going to be off. Your costs are going to be way higher than they should be. Okay, so we want to make sure that we're not double counting stuff. That's if we're looking at costs, because we just looked at revenue before, right? Or if you're looking at stuff with revenue, you can also double count things that would actually make stuff look like it's going to be higher than it is. And we need to make sure that we don't do that. Now, there's a way for us to detect if we're double counting things. So multi-collinearity. So linearity is a line. Collinearity is when we have two lines going the same way. Now, when we have multiple lines going in the same direction that are counting the same thing, we call that multicollinearity. So multicollinearity is when we have two lines or two slopes that are accounting for the same thing. And what it does, it inflates our numbers. It inflates our numbers. So guess how we're going to figure out if we have multicollinearity? We're going to call it a variance inflation factor. How much our numbers are being inflated by. That's what we're going to look at. And when we look at this number that tells us how much we're being inflated by, if it's too much, then we have multicollinearity. So when we look at our VIFs, or various inflation factors, anything above 5, we got issues. Anything above 10, we're unable to use. Because there are some things that inflate, right? And there are some carryover between things, and we're like okay with that a little bit. But what we care about is when it impacts, when it starts to impact our projections. And the number that we have to start worrying about when it impacts our projections are any VIF, various inflation factor. Any VIF that is, when the VIF is greater than 5, we have an issue. But when the VIF, various inflation factor, is greater than 10, whatever the two variables are that's creating that issue, we've got some problems, right? You can't use it. You can't use whatever the two things are because it's inflating it too much, and whatever numbers that you have are going to be way off. Does that make sense? The numbers that you're using are going to be way off, and we're going to have some serious problems with them. Okay, so our various inflation factors. And so we have to be careful with those. Okay, I want to show you one more thing, and then we are going to move forward. As well. So Garrison, give me a thumbs up if you can see this. Okay. So right here, we're going to look at some multicollinearity issues. We already looked at this, right? Did we look at the multicollinearity? Did we look at the multicollinearity already, Garrison? Or no? The slides. Yes. Okay. Because we did. I just want to see if we're listening. MR 16, 17, 18. Okay. So let's take a look at our various inflation factors. So here we're looking at our multicollinearity, right? What it is. So multicollinearity is when we have things that are highly correlated with each other. What does correlation mean? When two things are kind of highly associated with one another. Caffeine and energy. They're highly correlated. Does that mean that caffeine always gives you energy? No. But there's a very strong correlation with it, right? But it doesn't mean it affects everybody the same way. So correlation are when two things kind of go together. A lot of sleep and feeling rested. No sleep and not feeling rested, right? So correlation. So when we have two things that are highly correlated and they start to affect each other. So it can lead to unstable or unreliable coefficients, right? With a lot of standard error in it. And they actually start to inflate some of our problems. So we start to see large variations in our data. So large variations would give us like these huge confidence intervals, right? And so how do we detect multicollinearity? What we're looking at is our various inflation factors, right? And those of you that want to learn how to calculate it, this is what it is. So we're looking at them, we would get our various inflation factors, and anything that's above 5, right? So this is our VIF, and it's looking at price and all the other variables. So here we have price and all the other variables. Our VIF is 1, so it's good. If it was above 5, it would tell us that price with all the other variables is no good. And if it's at 10, then what we would do is we would take price out, because price would be highly correlated with other things. And that's what our VIF is telling us, is does price have issues with other variables, right? And if it is strongly correlated, we need to take action. We need to get rid of it, right? And so here we see that we have advertising and holiday. And do we see that VIF? 83. There's a problem there. So what do we need to do? We should get rid of probably advertising, because advertising has some problems there, right? We have a VIF, or we can get rid of holiday, but we have a problem there with them. So one of these we have to get rid of. So it's going to throw off our calculations, right? And this will throw off our numbers. So how do we deal with this, right? We can drop it. We can just drop that variable. We can drop it, and that gets rid of it. That's the easy way, right? If we have multicollinearity and we have an interaction, and we determine that it's only multicollinearity because of the slopes themselves, what we can do is we can square the data. And you're like, what? And when we start doing homework, I'm going to apply this. I'm saying it right now, and you're just like, it doesn't make sense. I get it. I'm lecturing, but as soon as we start to do this in real life, I'm going to show you how to do it, or we start doing this in our assignment. I'm going to show you how to do this and why it's important, because we may need to do this in our homework to make it work. And how tomorrow when we speak with Winnie, and hopefully when you're speaking with YSAM, you kind of got the gist of this. And if we had time to speak with more of the people, they will tell you kind of how important it is to learn this. I'm going to call it a tool. Because if you're in finance, your entire career is going to be about this stuff, regression, right? Slopes and betas and that type of stuff. And how do you fix it when you have something that's not working? So when we have a quadratic equation model, what we're looking at is we have something that's nonlinear. And how do we fix that? How can we fix this nonlinear model? We're looking at it, and so imagine we look at our assumptions. When you run regression, you draw the line. Linearity, independence, normality, equal variances. We look at our residual plot, and imagine if we see a smile or a frown. We're like, that's no good, get rid of it. Do we have to get rid of it? No. We can actually, and I know that here we are talking about a society now where everything is, I hate to say it, but everything's disposable, right? You have an old iPhone watch, whatever they're called, an Apple Watch, and the new one comes out. What do you do with the old one? Sell it on whatever or throw it away. A new whatever comes out, what do? You throw it away. Everything is disposable. Not everything, and everything shouldn't be disposable. Some things you can actually fix. And this is one of the things, this is a relationship that we can fix, right? This is something that we can actually fix. So we have something that's not working. We have some data that we are trying to fix, and we want to turn this data into information to where we can actually start to operate off of this. And imagine if you're trying to figure out how much money you're going to make next year based off of price, advertising, and if a holiday occurs, and price isn't working. And how are you going to really forecast your income if you can't use price. And so one way to do it is to take the data from price and square it. So you would take the whole Excel spreadsheet right there where it says price, all those numbers, and square those numbers. And so if that is like B2, you would just do B3 and make a new one of that squared data and run it. And what that should do is fix it. It should fix it. Not all the time, but typically it does. And that's what we try to do in the models. We try to square that data, right? We try to square that data by squaring it, typically, or square rooting. Let me say this. So squaring or square rooting the data could fix it. So that's what we're going to try. Also, if you have multicollinearity as well, squaring and square rooting it also fixes it sometimes as well. So let's take a look at what I mean. So I want to take a look at what the heck I'm meaning and how this actually works. Okay. So imagine you have some data. We're looking at the residuals. And you have that. Right? Those are all data points. And if we put a line to it, it would go like that. And if we have a line right here in the middle, it would be like that. You know how we can get rid of these data points here? Imagine if we squared the data, what it does is it's going to bring all those data points up. And then we would have something more, instead of like that, it would be more random. The data points would be everywhere. Because the ones that were down at the bottom would move up. And so sometimes, you know how we have our assumptions? You run regression, you draw the line. Linearity, independence, normality, equal variances. This is looking at, is a curvilinear or not? And so if we have a curvilinear, a quadratic model, we can square the data and fix it, and then use it. Or, in this case, we can square root it and bring those values down. So sometimes squaring it, other times square rooting it fixes it. Okay? So we can square the data or square root it, and to see which one actually works better. And so if we have one of these shapes in our model and says it's curvilinear, we can fix it. Also, if we have a problem with our various inflation factors, sometimes we can square that data and fix it to where it's not multicollinearity, which means that some of the slopes won't necessarily affect each other. Okay? Some of the slopes won't affect them. And that's why I was saying, like, how do you fix the data? How do you fix this stuff to make it work? Right? And it happens quite a bit. I was just about 6 weeks ago speaking with one of the owners of a company called Amazon, and CIO, and they were having some issues with their data and they needed to know how to fix it. I'm just like, did you guys forget Stats 101 or Stats 310? Sorry. Square the data. Like, what is that? Blah, 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 blah. We go through this whole thing. They finally square it. They got it to work. They fixed it. They ran it. It's good. Numbers are good. Right? They're now able to use that for projections. All right? Just want to make sure that we're clear on that. So I want to go back now and finish off this, and then I want to go back to our assumptions because I want to make sure that we're clear on the assumptions and what they mean. So again, what we want to do to make sure that we've fixed the model once we square the data, we want to compare our adjusted R-square of the old one to the new one. And if the adjusted R-square is better, then we're okay. Even if it's still a little bit off. So it's still a little bit of multicollinearity. As long as our R-square gets better, we're okay. Some people also will try to cleanse their data a little bit. What they'll try to do is they'll try to adjust the mean of their data. And what that's known as like centering your data, right? And so they try to center their data a little bit, and by centering the data to getting rid of some of the outliers and stuff, it could actually help you to fix your data, right? So they'll center it a little bit, try to get rid of some of these really crazy numbers, and by centering the data, they can fix it. That's a little bit more of the advanced stuff. I like to mention that just a little bit, just to make sure that we're all on the same page. We use that in the MBAs.